Show you the answers to the U-Try just in case you were struggling with them. That way we can see how to solve using the explicit formula. We can see how to utilize the explicit formula. And the whole goal of today's lesson was to make sure that we knew how to utilize the arithmetic sequences and when they're useful, when do we use them, why do we use them, why do we have them. Hopefully by now you realize they're great for using in long sequences where you don't really know where the term might be and you don't want to continue on that sequence forever and ever. So I've got the sequence 3, 6, 9, and 12. My a sub 1 is 3 because that's my first term. My difference is I'm adding 3 each time. So my difference is 3. So therefore my a sub n, using the explicit formula, so we should have probably written up here, and we need to write the explicit formula. Remember, this is our useful formula to find any term at any time. So our a sub n is going to be 3 plus n minus 1 times my difference, which is also 3. I'm going to distribute the 3 to my parentheses. So that gives me a sub n equals 3 plus 3n minus 3. Now I've got this 3 minus 3. Well, 3 minus 3 is 0. So therefore, my a sub n is just equal to 3n. So if I ask you to find a sub 10, all I'm going to do is anywhere I see an n, I'm going to replace it with a 10. Excuse me there, guys. Is equal to 3 times 10. So a sub 10 is equal to 30. Or you could have written it as 10 comma 30. Let's look at our second sequence. I've got 5, 11, 17, 23. My a sub 1 is 5. 5 to 11 is adding 6. 11 to 17 is adding 6. And 17 to 23 is adding 6. So my difference is 6. So if I'm writing the explicit formula here, I got my a sub 1 as 5 plus n minus 1 times my common difference of 6. I'm going to distribute the 6 into my parentheses. So a sub n equals 5 plus 6n minus 6. And combine like terms, so 5 minus 6 gives me a negative 1. So a sub n equals 6n minus 1. Now I want to find a sub 12. So this is my 12th term in the sequence. So instead of adding 6 12 times, I can just replace an n in my explicit formula with 12. So I have 6 times 12 minus 1. 6 times 12 gives me 72. So my a sub 12 is equal to 72 minus 1. So therefore, the 12th term of the sequence is equal to 71. You also could have written it as the ordered pair, 12 comma 71. All right, guys, you have the rest of the class to work on the homework. Have a great day.